This is a video for MEI Core Pure Mathematics, second order differential equations 1, homogeneous equations, 1.4, finding particular solutions given boundary conditions. Boundary conditions are when the information is given for two different values of the independent variable. For example, we may have y equals 0 when x equals 0 and y equals 2 when x equals 1. So we've got two different values of y for two different values of x. This problem is called a boundary value problem. Let's find the particular solution for this differential equation when y equals 0, x equals 0, and when y equals 2, when x equals 1. We've seen this differential equation before, and in fact the general solution has been given for us here. So we need to take both sets of boundary conditions, plug them into here, which will form two equations with two unknowns a and b. So starting out with y equals 0 when x equals 0, I'm going to get that 0 is equal to a plus b. And if I plug in y equals 2 when x equals 1, I'm going to get 2 is equal to a e to the 3 plus b e to the minus 5. Now because a plus b equals 0, I know that a is going to be equal to minus b, so I could rewrite this one as 2 is equal to a e to the 3 minus a e to the minus 5. So rearranging this gives me that a is equal to 2 over e to the 3 minus e to the minus 5. And if I times top and bottom by e to the 5, I'm going to get that a is equal to 2e to the 5 over e to the 8 minus 1. We've already said that a is equal to minus b, so we're going to get that b is equal to minus 2e to the 5 over e to the 8 minus 1. And so my particular solution becomes y is equal to, well, this constant 2e to the 5 over e to the 8 minus 1 times e to the 3x minus e to the minus 5x. And there's that written up neatly. You can see here I've used each set of boundary conditions to give me my two equations. So combining those two equations and working it through, I can get a value for a and consequently a value for b. And there's my particular solution at the end. So if we look at a plot for this solution curve, that's the curve that we've plotted over here. We can see that it goes through the point 0, 0, in other words y equals 0 when x equals 0. It also goes through the point 1, 2, and that's y equals 2 when x equals 1. So two distinct pieces of information, because they have fixed 2 points on the curve, have uniquely defined which of the curves we want out of the family, and therefore this is our particular solution. The next video in this sequence is 1.5, an auxiliary equation with repeated roots.